Welcome back, guys. This is a week 3 video covering the topic of lines of symmetry. A line of symmetry can be defined as a line that divides a shape into two parts that could lay one on top of the other identically. That means that if I folded this smiley face on that line, when I folded them on top of each other, the opposite sides would match each other exactly. Okay, a line of symmetry divides a shape into two congruent parts. In geometry, the word congruent means equal. Okay, so for this little bear here, if I folded it on that line of symmetry, both sides are congruent, they match. The image that you see on the left side is the exact same image that you would see on the right side. Okay, it's kind of like a mirror image. Okay. One way that you can tell if shapes are congruent is to use light. Okay, so I'm going to use a light table, and I know most of you don't have a light table at home, and that's fine. You can use just the light on your ceiling, you can use a lamp, you can use the sun, any type of light that you have available. Okay, because it's going to help you fold on those lines of symmetry to see if a shape actually has a line of symmetry. Okay, so before we actually start that, let's talk about the different types of lines of symmetry. Okay, we have vertical lines of symmetry going up and down, horizontal lines of symmetry going side to side, and then you have your diagonal. Okay, it could be diagonal this way, it could be diagonal that way, either way. Okay, so the first shape that we're going to start with is just a square. Okay, and what I'm going to do is I'm going to start with a vertical line of symmetry. I'm going to try and fold this square in half down the middle. Okay, and what I'm looking for, and the reason that I have the light table, is so that I can see if these black lines actually match up. Okay, and they do. And you can see that through my light table. If you hold it up to the light, which you can't see me do that on the camera, but if you hold it up to the light, you should get the same effect that I'm getting on my light table, okay? You should be able to see that the black lines underneath here match up with the black lines that are on top, okay? So this is a vertical line of symmetry, okay? Now shapes can have more than one at a time. Okay, so now I'm going to try the horizontal line of symmetry going this way. Okay, so I'm going to fold this way, matching up those corners. And what I'm looking for now is black lines through underneath these black lines, okay? And I don't see them, which means that they are matching up perfectly. Okay, so that is another line of symmetry. Okay, so we had a vertical line of symmetry and we have a horizontal line of symmetry. Okay, now what I'm going to do is I'm going to try a diagonal line of symmetry, and I'm going to do that by matching up the corners. So I'm going to fold this way. And I want to match up these corners to see if they will match up perfectly. And they do. Okay, when I'm looking through there, those black lines on either side match up perfectly. Okay, so this square does have a diagonal line of symmetry. Okay, well, if I have a diagonal line going this way, oops, and I was kind of off there, it's going to have a diagonal line of symmetry going this way. Let me match that up. Try to get it as perfect as I can. Okay. All right, you'll see the black line, the shadow underneath matches up with these black lines right here. So that's another line of symmetry. Okay, so the square is going to have 1, 2, 3, 4 lines of symmetry. Okay, now I'm going to try the rectangle. Okay, and I'm going to start with a vertical line of symmetry, folding this way. Okay, you can see through my light table that those sides do match up, so it does have a vertical line of symmetry. Oh, a little crooked there. All right, now my horizontal line of symmetry. Okay, so I'm going to fold this way. Okay, and I'm checking the dark black lines, not the purple ones, the black ones. Okay, they do match up. Okay, so this one does have a horizontal line of symmetry. Now a diagonal line of symmetry. Okay, so I'm going to try a diagonal line of symmetry. So I'm going to try to match these corners up. Notice what happened. Okay, try to ignore the purple marks for now. I'm worried about the black marks. Okay, so here's one side of my rectangle. You see the other side coming through the paper way over here. That doesn't match this. Okay, so the rectangle does not have diagonal lines of symmetry. It only has a vertical and a horizontal line of symmetry. And the reason that is because it doesn't have all equal sides. The square had 4 lines of symmetry because all 4 sides were equal. Okay, same thing doesn't work for the rectangle. Okay, next shape we're going to work on is an equilateral triangle. Okay, an equilateral triangle is only one type of triangle that we have. And what equilateral means is that all 3 sides are equal to each other and all 3 angles are equal to each other. Okay, so I'm going to start trying a line of symmetry this way. So I'm going to fold corner to corner there. And it does match up. Okay, so I do have a line of symmetry there. And don't be afraid to spin your paper around. Okay, that's really going to help you, especially in the case of this triangle. Okay, so I spin it around, and now this point is the top. Okay, so I'm going to try the same thing I just did. I'm going to match it up. Off my fold there. There we go. Okay, I'm a little bit off there. Okay, but this should match up. If I folded that correctly, it should match up. Okay, so this is a line of symmetry. Okay, and then I'm going to spin this point around to be the top. Okay, and I'm going to do the same thing. There we go. Okay, and you can see that matches up. Okay, matches up on either side. Okay, so I'm going to spin it back around. And there are your 3 lines of symmetry on that equilateral triangle. Okay, now, that being said, not all triangles have 3 lines of symmetry. Here are some examples of other triangles. This triangle only has 1 line of symmetry, and you can see it drawn right here. Okay, this is the equilateral triangle that we just talked about. Okay, here's another triangle, another acute triangle that only has 1 line of symmetry. This obtuse triangle doesn't have any lines of symmetry. Okay, so you can see that I tried here. I tried folding on this line diagonally, and you can see that it doesn't match up. Okay, those sides don't match up. Okay, and I tried vertically. Okay, and again, see this piece up here? That doesn't match this piece. Okay, that one has no lines of symmetry. Okay, this one has 1, this one has 1, this one has 3, and that one has none. Okay, so it just depends on the triangle that you're looking at. Okay, next shape is going to be a heart. That one's pretty simple. You can see if I cut this one right down the middle. Okay, you can see that those lines match each other. See, if I lift this up, you can see the same image underneath it. Okay, so this one has a vertical line of symmetry. You would not have a horizontal line of symmetry. As you can see, the pointed part sticking out underneath there, it doesn't match up. Diagonal as well doesn't match up. Okay, you can see the image underneath it does not match up. Okay, so the heart only has one line of symmetry. Okay, next I have a pentagon. I'm actually going to show you two pentagons. Okay, this first one looks kind of like a house. Okay, I'm going to fold it vertically. Okay, that is a line of symmetry. You can see those lines match up. The image on this side matches the image on that side. Okay, so that has one line of symmetry. However, if I fold horizontally, you can see that it does not match up. Okay, and if I did it diagonally, you can see that that does not match up either. Okay, so for this pentagon, I only have one line of symmetry. Okay, now there is a different kind of pentagon. We call this a regular pentagon. Okay, it's shaped a little bit different than this one is. Okay, they're still pentagons, they still have 5 sides. Okay, what I'm going to do is I'm going to try a vertical line of symmetry first. Okay, folding vertically, matching up those points. Okay, yep, that matches up perfectly, so that's one. Okay, this is another case where I'm going to spin it around and get a different point on top. Now this point is on top, so I'm going to fold it. This way. Oops, I didn't fold perfectly. There we go. All right. Yes, that matches up too. The black lines underneath, you can see the image matches it. Underneath, that's another line of symmetry. Draw that one in. Okay, so I'm going to spin it again to where this point is on top. And I'm going to fold. It's harder and harder to fold the more times you fold. There we go. All right, it matches up again. Matches up. Okay, so that's another line of symmetry. Okay, I'm going to spin it again. Okay, that matches up as well. So I'm going to draw that line of symmetry. Spin it one more time. So that point's at the top. And match these up as well. Like I said, it gets harder and harder the more times you fold that paper. All right. Okay, and there's your final line of symmetry right there. Okay, so on this regular pentagon, we were able to make 5 lines of symmetry. On this pentagon, we were only able to make 1 line of symmetry. The difference between these two pentagons, this one has all equal sides. That's why we call it a regular pentagon. Okay. Okay, a hexagon, it's going to be, this is a regular hexagon, okay, like this is a regular pentagon. This regular hexagon has 6 equal sides, so you're going to have 6 lines of symmetry on this shape, okay. The octagon, this is a regular octagon, has 8 sides, okay, but not all octagons look like this, okay. This is a regular octagon because all sides are equal. Okay, with a regular octagon, you're going to have 8 lines of symmetry. Okay. All right. This special one here, the circle, that's the most special one of all. The circle has an infinite number of lines of symmetry because you can fold an infinite number of times and have matching sides because there are no corners that you're trying to match up. So the circle is very unique because it has an infinite number of lines of symmetry. Okay. Let's try this one. Okay. The arrows. Okay, I'm going to try a vertical line of symmetry first. I'm going to match those up. Okay, those match up perfectly, so that is a line of symmetry right there, a vertical line. Now I'm going to try it horizontally. Yes, that matches up perfectly. Okay, so there is a horizontal line of symmetry. Now I'm going to try a vertical line of symmetry. I'm sorry, a diagonal line of symmetry. Okay, and you can see here that the other part of the arrow, you can see it right here, and if I flip it up, you can see where it is. It doesn't match up. See, the point from this arrow is over here, and the point from this arrow is down here, okay? So those two do not match up, okay? So we don't have diagonal lines of symmetry with this shape. We only have the vertical and the horizontal line of symmetry, okay? Now the reason I did this on paper instead of cutting the shapes out is because a lot of times you're going to be looking at a piece of paper with the shape that's not cut out. So if I look at this teddy bear, and I know there's something copied on the other side, so it might be kind of difficult to see, but you can see that the other sides of the teddy bear match up with this side of the teddy bear, okay? That means that these two sides are congruent. Now, if I try to do that with the fish, see if I can see the fish through there. I can kind of see the tail. You can see his tail comes out over here, okay? It does not match up with the circle that's here, okay? If that was a line of symmetry, I would have to have another half circle with smiley face on the other side, okay? So that is not a line of symmetry, okay? I hope this video helps you with some symmetry and the symmetry questions. Tune in for the next video.